since I know everyone in this class is ready to go, so loud and clear so we can hear it, so those people that decided to not show up today can hear this too. So, class?
Yes.
Thank you, I appreciate it. I can hear you. Tree? Vincent? Is that a huh? Yeah, okay. Anyway, all right, so looking at this, yesterday we talked about limits at infinity, and there's a couple rules to go along with it, especially with asymptotes. So we're dealing with some horizontal asymptotes at this point here. As this is going to infinity, I look at my leading coefficients. My degree is the same. So Christian, what is this limit going to be? It's what? It's not 1. So here, let me help you. Okay? So I'm going to evaluate this. So 3 times infinity squared minus 2 times infinity plus 8 all over infinity squared plus 1. Now, we're racing to infinity, okay? So, who's going to get there faster? Let's look. This is infinity squared over infinity squared. I'm only looking at the highest degrees, okay? Especially as I'm going to infinity, because if it is infinity squared plus 1, okay, like at the point of infinity, that plus 1 turns into nothing. And infinity squared plus or minus infinity, that's really not going to happen because it's infinity squared. It's exponential. It's growing ridiculously. In the end, it's really not going to matter. So the only thing that matters is right here. Racing to infinity. 3 times infinity squared over infinity squared. So it's basically what you're doing is, so it's going to be 3. That's how we get this, okay? So with the same degree, it's basically my horizontal asymptote. It's the same rule as the horizontal asymptote. So that means that this one is going to be, all right, let's see, Vincent, you get the second one. As this is going to negative infinity. 0. Why is it going to 0?
The degree on the denominator is higher.
Very good. Good job. Is it going to negative 0 though?
No.
Doesn't matter, right?
Sure.
Because it is taking to negative infinity. This is going to the left of my graph. All right, Tree, you ready? So this one here. What's the power? 4. Give me a rewrite it. How do I say what?
How do you say that? I don't know.
How do I say that?
5. 2.5. 30. Square. Not sure.
Okay, what did I say that we need to focus on?
Power.
The powers, right? Are they the same degree?
No.
Okay.
That's why I say that.
So before you started emptying out everything on your desk,
I need to find the
before you started emptying out everything on your desk, we were trying to do some notes. Vincent perfectly described on number 2.
That's not what you do.
Why?
Power on the bottom is 0. Not sure what the concept. Infinity.
The power on the bottom, okay, was greater, so it went to 0, right?
Yeah.
Okay. So what can you tell me about this one?
That's very high up.
The top is higher, right? So if the top is higher, is that's going, as it races to infinity, what's going to happen to my graph? Yes, it's going to go to infinity. So this is going to go to positive infinity. So it's going to go up, it's going to keep going up as I do this. Other limits at infinity. So the limit as negative x approaches infinity, as x approaches negative infinity of e to the x, it goes to 0. This side, the left side, it goes to 0. But now on the right-hand side, it's going to approach infinity because it's going up like that. So this is the graph for e to the x. So these are things that you should know. You should know. Highlight, underline, circle. Okay, you should know those things. There you go. Limit at infinity g of x of ln x. Now, what is this going to the left? As it goes to the left. As it goes to the left. Does not exist. Very good. Does not exist. It's not there, right? So at 0, anything to the left of 0, to include 0, does not exist. So I could say going this way does not exist. But the right-hand side, this one right here, this is logarithmic. As it goes up, it's going to keep going up. So as it goes to right, it's going to just keep going up, even though it's going to look like it's going up at a certain angle, and it's going to look like it's plateauing, but it's not. It's still increasing. So this is one that you need to know. Okay? These are things that you should know, need to know, and be able to look at, be like, oh yeah, that's a good thing. Pay attention. Application. Decomposition of salt in water. Salt dissolves into water as into sodium ions, like chloride ions, according to the law, uninhibited decay. This is my formula. So this is probably going to be one of the bigger problems everyone's going to have. Is this problem right here? Because they don't pay attention to my class. They just stare at the screen of whatever they're working on and not really care. Where A is equal to A of t, okay, that is going to be A of t, which is what it is over time. Okay, A0 is the original amount of undissolved, so that is my initial. A sub naught is where I'm starting at, the starting amount. Okay, original amount, undissolved salt. K is a negative number that represents the rate of dissolution. Why does it have to be a negative number? It's going to go down, but why? Think of the wording. Decomposition and dissolving. That's important. Okay? So, this relates into two separate types of problems. Growth and decay. A growth would have what type of K value? A positive. And so decay must be negative. So that right there is super important to understand. Negative number represents the rate of dissolution. If there is initially 25 kilograms of undissolved salt after 10 hours, there is 15 kilograms of undissolved salt remaining. How much undissolved salt is left after 1 day? So, let's see, before I do that, right here, and let's see. So let's start off with this. A of t equals A sub naught of EKT. Now, initial amount. What was my initial amount? Almost heard you. 25. Right here, 25 kilograms. After 10 hours, there's 15. So, go back. My initial amount was how much? 25. E, K. What else did it give me? 10 hours. And 10 hours resulted in how much left over? 15. You have to follow this out and write it out precisely so you know what it is you're talking about, because these are going to be the problems that you're going to struggle on. Because this is just algebra.
So the K, what would we plug in for K?
We don't have it yet. But since we have this equation, how many variables are here? 1. E is not a variable.
Oh,
E is a number. There's only one variable. So if there's only one variable, can I do a little finagling? I can do some finagling as long as I have my initial information like this, and then I can plug that amount in to my next one. So let's go ahead and do a little bit of math. So divide both sides by 25. So that's going to give me 3 over 5 is equal to EK times 10. How do you undo an E? Natural log, ln. So you ln both sides, right? So if I ln both sides, I'm going to get ln of 3 over 5 is equal to 10k. And then I could, to get k, I would just divide both sides by 10, right? There you go. So there's my k value. So now I can go through and write this out. So my initial A sub naught was 25. My k is going to be ln 3 over 5 divided by 10. And now I could use that information to solve any other time or solve for any other quantity of dissolved salt left. So I could figure out either of those just by going back to my problem. Let's see what the problem says now. Okay, boom, boom, boom. Okay, remaining, how much undissolved salt is left after 1 day? Okay, 1 day. So what am I plugging in for 1 day? 24. Why 24? 24 hours, because my initial's in hours, right? So my time of my equation is in hours. So that's super important, because a lot of people are going to make this mistake and put in just 1 and just call it a 1 day. But it is in hours, so you have to use that unit also. No, thank you, thank you. All right. So I'm looking for A of 24 is going to be equal to 25 e to the k. Tree, do me a favor. Can you not play with that right now? Because I'm going to get pretty salty here in a moment. ln. Can't focus because I hear this ding, 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 ding. So it's pretty rude. All right, and what else am I plugging in here? 24, sorry. Please, understand? Yeah, yeah. So don't play with that. It's super rude. It really is. I know that you don't care, but I do. I'm trying to do this. All right. So right here, all I have to do is just plug all this in. Do I want to do it by hand? So let's go ahead. If it was something easy, like logs, I could plug in some logs if I have the same base or something like that. I could do that, but no, I don't want to do that. So let's go ahead and try my calculadora. Okay, so I am trying 25 E of my control divide. This is ln of 3 over 5 over 10 times 24. Wow, that's kind of weird, isn't it? Is that what my answer is supposed to look like? No. Your calculator is super smart, so it actually factors out for you. So what you're going to do instead is hit Control Enter.
Does that work for the ones we have too?
Yeah, this is, I finally got the one that you guys have. So yes, this is, so if you see some weird stuff like that, it's Control Enter. So if you notice, it goes back to my original problem right here. Boop, 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 boop. There you go. And so what does that mean? What is that answer going to give me? How much what is left after 24 hours or 1 day, right? Now, this is calculus. AP, always 3 decimal points. So my answer is going to be 7 point what? 337.
Is AP, can you not do more than 3?
And are these in grams? kg?
Yeah.
Okay. No, AP is always round to 3.
Always?
Always. That's the standard, round to 3. If you're ever rounding something, you have to round to 3.
Can I go further?
What part of that?
No. Can you not like go further, like decimal places?
No.
It has to be 3.
Yes, that's the standard. Round to 3, always. If you're doing it, you have to round to 3.
Let's see, it's different.
Okay, but I'm pretty sure it wasn't, but yeah, it's always round to 3. Anyway, so we just solved A. Let's go solve B now. How long will it take until 12 kilograms of undissolved salt remains? Now, instead of plugging in for the time, I'm plugging in for the amount of salt left over. So I need to use the same formula, but this time I'm solving for T instead. And I'm going to insert another page here. And so it's going to be so this is going to be what they say, 12?
Yeah.
Okay, 12 equals 25 e to the ln 3 over 5 divided by 10 times t. All right, let's do a little bit of algebra now. So divide both sides by 25. ln both sides. So it's ln of 12 over 25 equals ln of 3 over 5 divided by 10 times t. And then from here, I'm going to divide both sides because I'm trying to get t by itself, right? So this is just going to look ugly. Go back to the calculator. Three over 5? Okay. Ah. I lost my 3, didn't I? There you go. There you go. Did I punch it in right? Okay. All right, Control Enter. And what does that mean?
That's how many days.
How many what?
Days.
Days? What are my units?
Hours.
Hours. There we go. There we go. So my T, since I'm solving for T, my T is in hours. So that's important. So I'm going to say that that's going to be what? 14.368
368 hours.
So 14.368 hours to get 12 kilograms left. My last part to this, find the limit as t approaches infinity. So A of t which I'll write out this side right here, which is 25 E ln 3 over 5, 10 times t. What do you think's happening now? Why do you say it's going to be 0? It is decreasing, right? The negative is not up there. Why is the negative not up there? It is, but how? Natural log of 3 over 5, right? Natural log 3 over 5, so ln 3 over 5 turns in ln 3 minus ln of 5. That's where the natural log 3 over 5, and that's where my negative is. Even though it says it is, it doesn't say it negative, this is declining, right? And so if this was a positive number, what would happen as we take that into infinity? It's going to go up, right? But we already know that this is a yeah, so that word. So I know that this is actually going to go eventually to the point where this is going to go to 0, right? So negative, it's eventually going to make it to 0, right there. And so therefore, everything is going to approach 0. So that means that it's all going to dissolve over time.
If we had a positive times our k value, would it be approaching the same limit everything would just be approaching infinity?
It would be approaching infinity, because would that keep going up over time?
Yeah.
So, yeah, I have a couple zombie apocalypse type problems eventually that we're going to start doing with this same thing. And so, yeah, there's a rate of infection of blah, 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 yeah. And so at some point, it just infects everyone. All right, so let's answer the last part. Bless you, I think. So we already interpreted the answer found in part C. That over time, it is going to go to 0. It's all going to dissolve. And if it was a positive, we said that it would just be increasing up to positive infinity. Alrighty, and that being said, before we go, because we have, let me see, 1, 2, 3, we got 3 more slides. We're going to do these slides on Tuesday. So make sure you guys all like,